Hi everyone, welcome to my channel. In this video, we are going to review the first unit of apcalculus, AB and BC. Okay, let's get started. Okay, let's move to the first problem. Here a salesman tracks the number of cars he sells through the model C. Okay, and here C of M is the number of cars sold and M is the month for the months between 0 and 24 months. Now let's see what does C of 10 represents. Here you can see the C of 10. The C of 10 represents C is the number of cars sold and 10 represents the month. That means this represents the number of cars sold in 10th month, right? Let's move to the next question. Here you can see here the C of 16 minus C of 8 over 16 minus 8, what does represent? You know, f of b minus f of a over b minus a. So this is the average rate of change of the function f from x equal to a to x equal to b. Okay, here C represents the sales of the cars. That means this quantity represents the average rate of change in the number of cars sold between 8th month and 16th month. And let's move to the third one. So here you can see the C of 7 minus C of 6.999, which is very close to the 7, right? Okay, that means this average rate of change is the estimated rate of change of the number of cars sold at the month 7. You can see these two are very close to the 7, right? The difference between these two are very minimal. So this is an average, estimated average rate of change, or you can say it is an instantaneous average rate of change, instantaneous rate of change of the cars being sold per month on the 7th month, right? To 0 square root of x plus 19 minus square root of 19 over x. Okay, let's evaluate this limit. You can see by the direct substitution of the limit you will get so it is the 0 over 0. It is a undeterminate form, right? So we have to rewrite this expression as a by using some algebra manipulation. So let's rewrite limit x tends to 0 square root x plus 19 minus square root 19 over x. So can we factorize the numerator? Sorry, can we rationalize the numerator here? So that is x plus 19 plus 19 over square root of x plus 19 plus 19. Now, so you can see the numerator we have a plus b, a minus b times a plus b. So that is the formula we have, a square minus b square. So that is here a equal to square root of x plus 9. So that is x tends to 0 square root of x plus 19 whole square minus square root 19 whole square over x times square root x plus 19 plus square root 19. So this is limit x tends to 0. So the square root of x plus 19 is, which is x plus 19 minus 19 over x times square root x plus 19 plus 19, right? Here the 19 get cancelled and x get cancelled. So that is limit x tends to 0 1 over square root x plus 19 plus square root 19. So this is equal to limit x tends to 0. So you can substitute the limit here. So that is 1 over square root 0 plus 19 plus square root 19, which is 1 over 2 root 19. Now let's move to the next one. So limit extends to negative 3x plus 3 over x square plus 2x minus 3. Okay, you can see by the direct substitution of the limit, you will get the indeterminate form 0 over 0. Okay, so here we have to factor the denominator. So limit x tends to negative 3. So we have the x plus 3 over, so we have x square plus 2x minus 3. So the factors are x plus 3 and x minus 1. So x plus 3 get cancelled. This is the limit. X tends to negative 3, 1 over x minus 1. So now you can substitute the limit value, that is the 1 over negative 3 minus 1, which is negative 1/4. Now let's evaluate this limit. So limit extend, we know here we have one formula, limit extends to 0. We have sin x over x equal to 1. So now we have to rewrite this as a rewrite this function as to apply this limit. Okay, so limit x tends to 0. So we have the sin x sin square 3x over, so can we divide 3x and multiply 3x here, over, this is equal to sin square 5x over, okay, divide 3x whole square, 3x whole square, here the 5x whole square and 5x whole square. So now this becomes limit x tends to 0. So sin 3x over 3x whole square times 9x square over, we can apply the limit to the denominator also, that is limit x tends to 0, sin 5x over 5x whole square times 5x square, that is a 25x square. Now you can apply the limit, so this is the 1 over 1, so limit x tends to 0, sin 3x over 3x is just 1 whole square, and here the denominator we have the 9x square. Here the limit as x approaches to 0, so sin 3x over x is 1 and 1 whole square is 1 square times 25x square. So here x square get cancelled. So this is 9 over 25. Now let's move to the next problem. So we have limit, so we have to find the limit as x approaches to 2 from left side. What is this value? So you know this absolute value of x minus 2 over x minus 2, which is equal to x minus 2 over x minus 2 when x is greater than 2, negative x minus 2 over x minus 2 when x is less than 2. So as x approaches to 2 from negative means we have to use this piece. Okay, so that is limit x tends to 2 minus, so we have to use this piece, that is a negative x minus 2 over x minus 2. So that is the limit x approaches to 2 minus, so this one is negative 1, which is limit is negative 1. And here we can use the factorization. Here by the direct substitution you will get the indeterminate form 0 over 0. So let's factor the numerator. So limit x tends to 10, so x square minus 5x minus 50, so minus 50 is, so that is the x minus 10 and x plus 5, the factorization of the numerator, and the denominator we have x minus 10. So x minus 10 get cancelled, that is limit x tends to 10, x plus 5. Now you can substitute the limit, that is the 10 plus 5, which is 15. here. So by the direct substitution, you will get the indeterminate form. So we have to simplify this expression. So limit x tends to 0, 1 over x plus 1. Can we write 1 as a x plus 1 over x plus 1 over x? Now we have limit x tends to 0. So this is 1 minus x minus 1 over x plus 1 over x. So here 1 get cancelled. Also x also get cancelled. So this is the limit x tends to 0, negative 1 over x plus 1. Now you can substitute the limit, that is the negative 1, 0 plus 1, which is negative 1 over 1. This is negative 1. So the limit is negative 1. Now let's move to the next problem. So this is a function given f of x equal to sin x when x is less than negative pi, tan x. Function is defined as a tan x when x is between negative pi and pi over 4, and cos x when x is greater than or equal to pi over 4. Now find the following. So we have to find the left limit of f of x as x approaches to negative pi. You can see as x approaches to negative pi, so this one, so the function is sin x. That means sin pi, sine of negative pi. So this is equal to sine of negative pi, which is 0. And the second one, what happens to the limit x tends to negative pi f of x? Okay, so we have to evaluate the left hand limit and right hand limit. You can see we have the left hand limit is 0. On the right hand limit, so tan 0 is, so tan limit x tends to negative pi. From right side we have tan x, that is the tan negative pi, which is also 0. So that means we have the right hand limit and left hand limits are exist and they are equal. So therefore the limit is 0 here. Now move to the next one. So limit f of x as x approaches to pi over 4. So as x approaches to pi over 4, we can see from the left side, if you move to the pi over 4, that is the tan x. So tan pi over 4 is 1. So the left hand limit is 1. So limit x approaches to pi over 4 from the left side f of x, which is 1, and the right hand limit is limit as x approaches to right side, x approaches to pi over 4 from right side, the function defined as a cos x. So that is the limit is limit x approaches to pi over 4 from right side f of x, that is equal to cos pi over 4, that is the root 2 over 2. Since the roots are not equal, here the limit is does not exist. And finally we have f of pi over 4. You know the function is defined at x equal to pi over 4 or greater than pi over 4. The function is defined as cos x. That means f of pi over 4 is cos pi over 4. So that is equal to root 2 over 2. Now give the value of each statement. If the value does not exist or either does not exist or undefined, so we can use this graph of the function and evaluate all these limits. Okay, so we have the limit. What is the limit as x approaches to 3 from of f of x? We can see the graph as x approaches to 3 from the left side, the value is function value approaches to 2. So as x approaches to 3 from the right side, the function values are approaches to 2. Therefore, the limit is 2. And the second one, as x approaches to 1, what happened? As x approaches to 1, the function values are approaches to 4. Okay, it doesn't matter whether the function is defined or not. To find the limit, we have to consider the approximating values only. So that means as x approaches to 1, the function values are approaches to 4. As x approaches to 1 from right side, the function value approaches to 4. So that means both left hand and right hand limits are exist and they are equal. The limit equal to, as x approaches to 1, that is a 4. And f of 3. So from the graph f of 3 is, so here f of 3 has a hole, that means it is undefined. And f of negative 4, f of negative 4, sorry, f of negative 2. So from the graph f of negative 2, you can see there is a solid dot, so that is the function value. So therefore f of negative 2 is negative 2. And limit extends to 2 f of x. So what happens when we move to the 2 from uh, left side, the function values are approaches to 3, and right side the function values are approaches to 3. So that means which is 3. And limit extends to negative 2 from right side. So negative 2 from right side, you can see as x values are approaches to negative 2, from right side the function values are approaches to positive 2. So therefore the limit is positive 2. And f of 1, you can see f of 1 is defined as a this dot line, solid dot, that is 2. And the limit x tends to negative 2 from left side. So you can see as x approaches to negative 2 from left side, the function values are approaches to negative 2. So that means the limit is negative 2. Okay, so this is the, we can find the limits. Now let's move to the next problem. So the 19th, so let g and h be the functions defined by g of x is defined as a negative 1/4 x square minus negative 1/2 x minus negative 9/4, and h of x is defined as sine of 5/2 x minus 1. If f is a function that satisfies g of x which is less than or equal to f of x and h of x, for all x, what is the limit of x tends to negative 1 f of x? Okay, so we know the squeeze theorem. So if the limit of, so limit of x approaches to negative 1 g of x exists, and that is equal to L, and limit of x approaches to negative 1 h of x exists, and that is equal to L, since g of x is less than or equal to f of x is less than or equal to g of h of x, that means the limit of f of x is, limit x tends to negative 1, f of x is also, we have the same limit. Okay, so now let's find the limits of this function. So let's find the limit x approaches to negative 1 g of x. So that is limit x approaches to negative 1. So g of x is negative 1/4 x square minus negative 1/2 x minus 9/4. As x approaches to negative 1/4, you can direct substitute the limits. So negative 1/4, negative 1 whole square is positive 1. That is the positive 1 of negative 1/4 is still negative 1/4. And negative 1/2 and minus 1, that is the positive 1/2, and minus 9/4. So negative 9/4 and negative 1/4 and 9/4, that is the negative 10/4. And 1/2 can be written as 2/4. So that is the negative 8 over 4, that is the negative 2. So therefore the limit extends to negative 1 g of x is negative 2. Now let's evaluate the second limit. So limit x approaches to limit x approaches to negative 1 h of x. Okay, so that is, So limit x approaches to negative 1, h of x equal to sine pi over 2 x minus 1. As x approaches to negative 1, this is the sine of negative pi over 2 minus 1, and sine negative pi over 2 is negative 1 minus 1, which is negative 2. So therefore we have the, so negative 2, the limit extends to negative 1, h of x is negative 2, and limit extends to negative 1, g of x is also negative 2. So by the squeeze theorem, we have limit extends to negative 1, f of x is also negative 2. And finally, we have solved this problem. Let's solve the final problem. So we have f of x equal to this one, x square plus 10x plus 21, and over x plus 3. Create your own table of values to help you evaluate this limit. Okay, you can see factor the numerator. So 21, that is the 7 3s, so x plus 7 and x plus 3 over x plus 3. So you can see x plus 3 can cancel, that is the x plus 7. Okay, so let's use some values since we need to evaluate the limit at x equal to negative 3. So let's see, this is the negative 3, negative 2, sorry, negative 4, negative 5, and negative 2, negative 1, 0. Okay, and the output values are x plus 7, so we have to add the 7 to the input value. So negative 5 plus 7, that is the 2, negative 4 plus 7, 3, negative 3 plus 7, 4, negative 2 plus 7, negative 2 plus 7, 5, negative 1 plus 7, which is 6, and 0 plus 7, which is 4. Okay, now use this value, use this table and evaluate this limit. As you can see, as x approaches to negative 3 from left side, the y values are approaches to 4. As x approaches to negative 3 from the right side, the y values are approaches to 4. So that means this limit is, this is equal to 4. Okay, so this is the review of the first unit. Hope you like the explanation. Thank you for watching.